vectors. So as the first step into multivariable calculus, this will build on the foundation of vector calculus, and it's always generally good to know for directional derivatives and gradients, but we'll get to that later. So a vector can be represented as an arrow with magnitude and direction, okay? From Despicable Me, vector, the characters said he had magnitude and direction, so that's what it means. So we can represent the vector A by breaking up into its components, right? So let's say we have a x direction, a y direction, and a z direction. So in the x direction is a1 I hat, y direction is a2 j hat, and z direction is a3 k hat. Okay? Now let's say we want to find the length of these vectors. Alright, so again, we're going to go on a two-dimensional plane because I think it's easier to visualize it than a three-dimensional plane or a three-dimensional graph. So let's say we have our vector, this, A. We want to find the length. So we notate the length, this, as the absolute value, brackets. Okay? Well, let's do this. We have our component, we have our x component right here, so we have a1, and we have our y component right here, which is a2. Alright? So now, if we look at this, well, if we connect that right here, it gives you a right triangle. Right? And now we can use Pythagoras Theorem, so we know the length of it, length of the vector is the square root of the components squared. So a1 squared I hat, or no, a1 squared plus a2 squared plus a3 squared. Okay, and this goes on for how many different components you have. So if the vector in 8 dimensions, you want to find the length of it, you should put all your components there. Right? So what if we want to multiply a vector together? So let's say again we're going to draw, actually let's use this graph right here. Let's say we had another vector b. We wanted to multiply this together. Well, how would we do it? So as we see, there are these two angles theta right here. And it kind of looks like we kind of want to use something with the length of these vectors, alright? And something with the components of these vectors. And we can kind of see it here. So we would say the length of this vector times the length of this vector. Okay? So that'll give you a part of the component, or part of the multiplied vector. But also we have this angle right here, this angle cosine theta, so this angle theta. And now let's rewrite this. So we get length of A times length of B times cosine theta. That's equal to A dotted with B. So this is called the dot product. So essentially what the dot product is the components of the vector, so A dotted with B. So we get A1, B1, so the components multiplied, plus all the components multiplied, and then you would just add them. So it's the sum of the components A I and B I. Okay? So that has been vectors.